All right, so we're going to talk about continental drift. Let's do this. Okay, so the idea was essentially that Pangea was a super landmass and broke up, and current day we have our continents the way they are, separated by vast oceans. Um, and so what you need to know is Pangea, the idea of Pangea being supercontinent, that's just the last one that has happened. It's happened numerous times throughout Earth's history where it was a super landmass, broke up, super landmass again, broke up. You know, it happened quite a few times. The last one is Pangea, super landmass, and now we're broke up again, and eventually it's going to come back together again to form another supercontinent. So, yeah, so that's kind of that's the origin of Earth's plates and what happens as we go through, you know, this the movement of these plates. So, there's a couple pieces of evidence that you need to know. So the first piece of evidence is that it fits together like a jigsaw. When you take South America and Africa, they seem to fit together. And you take, you know, the North America and Europe, you can kind of fit some of these together. So it's interesting. And a guy named Alfred Wegener is the first person on record that kind of put that together. So that's evidence number one. Evidence number two is after they're fit together like jigsaw puzzles, you start to see some fossil evidence will pop up. This picture right here, you can see when you put South America and Africa together that the fossil evidence kind of matches these areas where they fit. So that'll be evidence number two, which is fossil evidence. But so the first one is jigsaw puzzle. Second, fossil evidence. Third, here, rock strata. So geological records, nearly identical rock layers on continents that would have fit together. That is evidence number three. So you put this puzzle continents together, and you can see the rocks match, the rock record matching across continents. Number four is coal in the poles. So if you know what coal is, you know that it's living organisms that's no longer living, clearly dead. And so why would there be coal in the poles where there is just not a lot of life? So that is evidence that the poles, the polar areas, used to be located in warmer climates where life was. So now they are located elsewhere in these polar regions of Earth, and evidence number four of Wegener's 5 pieces. The last one is tropical plants found in the Arctic. So plants that live primarily in warmer regions found on multiple continents, including Antarctica. If Pangea were true, the continent would have been in a warmer climate, allowing for that plant to survive. And so they found this fossil evidence of tropical plants in places that are no longer tropical. And that's the 5th piece of evidence that Wegener had. So, but he did have a major hole in his theory. He could not explain the how, why, or when this occurred. So he started hypothesizing, and he proposed that maybe the spinning of the Earth somehow caused the continents to move, and they had plowed through the oceans. But this idea was quickly shot down by physicists and geologists that knew better. They knew that the Earth spinning cannot cause less dense continental crust to plow through more dense and rigid ocean crust, and that it was silly. And so because Wegener did not have the mechanism, the how, the what that created, all of his evidence, his ideas were rejected by the scientific community and would not be revisited until after his death. So he died in Greenland on an Arctic expedition doing his work, and sad day. So, But there, there was huge advances in technology that happened, and then during the 30s and 40s, especially in the sound waves, and then scientists began bouncing sound waves off the ocean floor in an effort to make up a map of the ocean floor. This led to a major discovery in the middle of the Atlantic, specifically, but in other areas as well. They found a chain of underwater mountains. And so the mid-ocean ridge here is what they're specifically talking about. This is the first one that they had found. And then they were wondering, what the heck, where did these ridges come from? And so in the early 60s, Harry Hess proposed this now famous theory called seafloor spreading. He proposed that less dense basaltic magma from beneath the Earth's crust was pushed upward through the denser ocean floor. This upward seafloor was then forced outward from the opening, spreading the seafloor apart, which we learned a little bit more when we learned about divergent boundaries, right? So this became evidence for this seafloor spreading. In 1968, they started collecting samples from the ocean floor that would support Hess's theory. They collected rocks from the ocean floor and also drilled samples from different distances between the ridge and the coastline. Scientists found that the youngest rocks are found along the mid-ocean ridge and became increasingly older as you move outward and away from that ridge towards the coastline of the continents. So these findings supported both Hess's theory of seafloor spreading and Wegener's theory of continental drift. So together, that created the common day theory of plate tectonics. When rocks containing cool iron, the iron aligns itself with the Earth's magnetic poles, much like a compass does. So you don't really need to know much about this, okay? It's just a Earth fun fact that, the scientists have determined that the Earth's magnetic poles have reversed multiple times. So over a few 100,000 years, polar north becomes polar south. It just kind of switches. It's a magnetic reversal that occurs. And we're actually getting close to the next polar switch. So in the next couple thousand years, possibly, maybe even less, the magnetic north will switch to become magnetic south, rendering all of our compasses useless. So they'll have to go back and re-engineer some compasses after this does happen. But they have found the evidence in the rocks because the rocks keep the record of the magnetic pole reversal. These iron rocks do. They flip their polarity as you move away from the ocean ridge. I'll show you in a picture of that in just a second. In other words, the seafloor spreading theory fits perfectly with other theory scientists had for some time. And this is that picture I'm talking about. So we have the mid-ocean ridge, we have a magnetic polarity going, north, for example, and then it will switch. So you can see we have, we'll have the rock record will have one polarity, and then over time, it'll switch, and then over time it'll switch. And so if you take records from the rocks here, for example, where my mouse pointer is, that'll be record of the north, polar north. This could be record of polar south, and this could be record of polar north. So as you take these rock records, you can see the magnetic reversal in the rocks. And that's pretty much all you need to know about that the magnetic reversal was just help support the theory of seafloor spreading. And that pretty much is the end of it. So just to wrap up one more time, we have continental drift. There was 5 pieces of evidence that Alfred Wegener came up with. Number 1, jigsaw puzzle. 2, fossil evidence. 3, rock strata. 4, coal in the poles. 5 tropical plants in the Arctic. I want you to remember them in that order because that's the order that he found them. So JFRCT, jigsaw, fossil, rock, coal, tropical. That's the 5 pieces of evidence that he had, but he did not have the mechanism. He did not know how it was happening. So his hypothesis was shot down. He ended up dying without having that evidence, and so he wasn't taught about in classes during that time. And then technology kept advancing. They figured out how to read the ocean floor. Boom, seafloor spreading. Boom, Wegener's a genius. Now we have the common day theory of plate tectonics.